Welcome to Engineering Visualization channel. So today we are going to discuss about scales. Okay, scale is a device which is used to measure any kind of objects which are having various sizes. Okay, it is a device which is used to measure any kind of sizes. You can see, so there are different types of scales over there with a different gradation, and they'll be used for different kinds of engineering works. Okay. So types of scales you can see here, basically we have two types of scale, engineering scale and graphical scale. So engineering scale we have full scale, enlarging scale, reducing scale, plane scale, diagonal scale, Vernier scale, comparative scale and scale of chords. So here a full scale means here if it is if any kind of drawings were drawn to the exact size, we call that as full scale. If the dimension of an object is very less, so we need to enlarge, like components of a wristwatch which is having very minute components, so needs to be enlarged. Okay, the same way reducing scale means here the dimensions of a buildings, bridges needs to be reduced, so in those cases we are going for the reducing scale. Okay, so based on the requirement we will be selecting the full scale, enlarging or reducing. So in the full scale, either if the dimensions are of very less, say 30 mm diametrical circle has to be drawn, means same way. So representative factor. Okay, now as we have seen enlarging or reducing scale, so here this representative fraction plays a very important role here. So by multiplying this representative fraction with the actual length of the scale, so length of the element in the drawing we can able to find out. So we can able to reduce it also, we can able to enlarge it also by multiplying this representative fraction. So this is a very important aspect. Okay, using this representative fraction we can able to enlarge or reduce, or we can able to draw with respect to the actual scale of the drawing. Okay, and the same thing we see in the type of scale. Okay, in the case of full scale it is 1:1. If it is enlargement scale means here the maximum size is to 1. Reducing scale means 1 is to the reducing scale. Okay, in the same case it is recommended in the BIS standard. You can see full scale 1:1, reducing scale 1:2, 1:5, 1:10, and enlargement scale. So the first we write the bigger number, and then the is to 1 we write 50:1, 20:1, like that. So what are the important things we require for construction of scales in engineering drawing is, so as we have to identify whether we are drawing for using plane, diagonal or Vernier, and the representative factor, and the maximum length of the can be measured from the scale, or minimum length can be measured with the scale, that is least count, and then with the multiplication of representative factor, so length of the scale can be easily find out using a particular formula. So here we see the types of scales here now: plane scale, diagonal scale, Vernier scale, comparative scale and scale of chords. So plane scale here basically it is used to find out two consecutive units. Okay, example like meter and decimeter, or it can be feet and inches. So in those cases this plane scale is suitable. Okay, where we require only two consecutive units to be measured. Okay, with the immediate subdivision. But this diagonal scale, it is having a little bit higher standard compared to the plane scale. So here we can go for the three consecutive units. Okay, you can see that is meter, decimeter and centimeter. So diagonal scale gives the more precision compared to the accurate or precision compared to the planar scale. So Vernier scale here it is usually it is also to measure the three consecutive units, and here and it is in metric scale. Okay, so here basically it consists of two kinds of scales here. One is main scale and Vernier scale. With the help of this main scale and Vernier scale we can able to find out most precision dimensions. Okay, so it is basically used in vernier calipers, screw gauges and micrometers. Okay, so it can be used there. Compared to scale means here the different dimensions of a in a map we can able to measure parallelly both kilometers and hectometers by using in a comparative scale by the representative factor, okay, like miles and furlongs. Scale of chords basically used where we want to find out the angle where we don't have the protractor. So it is basically used to find out the angles, okay, angles you can able to measure or set any angles using this set of chords. Okay, so that completes the topic. Okay, so you can subscribe for the channel and hit on the bell icon for the latest notifications and share it to the maximum students so that they can be benefited. Thank you all. Thank you for watching the video. Representative factor. So if the actual length of the object is 50 feet, so using representative factor we can reduce it to get the actual length of the diagram. So actual length of the diagram is different and actual length of the object is different. You can see in the example 50 feet of the actual length of the object using representative factor of 1 by 25, you can get actual length of the diagram is 2 feet. The same thing here we represented by means of a simple formula. RF is equal to LOD by actual length of the object. Important parameters to be considered for learning scale. So there are 6 important parameters. One is size, representative factor, units, types of scales, and maximum length of the object and length of the scale. You can see in the sizes we have 3 types of size: full size, reducing scale, and enlarged scale. So using representative factor we can able to reduce the maximum size into the required size, and we can enlarge the minute size into the actual scales, and then using the different types of units we can able to do the conversions. And then different types of scales were used based on the requirement, like plane scale, diagonal scale, comparative scale, Vernier scale, and scalar scale. And Lmax is nothing but maximum length of the object we should consider when we drawing it. Okay, so length of the scale is nothing but it is the reduced scale. You can see therein we have used the RF, nothing but representative factor, wherein we can use the maximum length of the object. So there are some cases we can use the maximum length of the objects. In some cases we consider the based on the requirement we can choose the length here. So these are the important factors we should consider before we start learning the scale. So each of these things we should be clearly understand. You can see RF, using RF factor we are getting different values. Say if we are using the full scale, the RF factor is RF is equal to 1. If you are using a reducing scale, so RF factor should be less than 1. If you are using a enlarging scale, the RF factor greater than 1. So like this we should use it. Units. Here we have 3 types of measurements. One is linear measurement, square measurement, and MKS or FPS system. You can see in the linear measurement we have 10 centimeter is equal to 1 centimeter, 10 centimeter is equal to 1 decimeter, 10 decimeter is equal to 1 meter, like that. The same way in square measurement we have 100 mm square is equal to 1 centimeter square, 100 centimeter is equal to 1 decimeter square, 100 decimeter square is equal to 1 meter square, and 100 meter square is equal to 1 acre, and 100 acre is equal to 1 hectare, 100 hectare is equal to 1 kilometer square. In the same way in MKS or FPS system we have 25 mm is equal to approximately equal to 1 inch, and 12 inch is equal to 1 foot, and 3 feet is equal to 1 yard, 220 yard is equal to 1 furlong, 8 furlong is equal to 1 mile. Say you want to see the conversion of each of these. Say 1 meter is equal to how much mm means, you just see that 1 mm is equal to 1 meter is equal to 10 to the power of 3 mm here. So we need to go with respect to the 3 rows here. Okay, in the same way 1 kilometer is equal to 1 2 3 4 5 6, so 10 to the power of 6 mm. In the same way you can see with respect to the 1 yard here. 1 yard is equal to 3 into 12 into 25 mm. Okay, in the same way you can find it for 1 meter square is equal to how much mm square. Here it is 100 into 10 to the power of 3 mm square. So like this we will find out the conversion of the units. Okay, so conversion of the units is very important here. So how much centimeters are equal, how much mm, how much one decimeter is equal to how 100, how much centimeter we can able. Welcome to engineering visualization channel. Today we are going to do a problem on plane scale. If 1 centimeter long line on a map represent a real length of 4 meters, calculate the RF. So draw a plane scale long enough to measure up to 50 meters. Show a distance of 44 meter on it. So RF means representative factor is equal to drawing length by actual length. So drawing length is nothing but 1 centimeter. Actual length is nothing but 4 meters. Okay, I'll be writing that 1 centimeter by 4 meter. So now we will convert all these things in same common format. So 1 meter is equal to 100 centimeter. So here I'll be writing 1 centimeter by 4 into 100 centimeter. So the here representative factor will be 1 by 400. Okay. Now we have to, using this representative factor, we have to calculate the drawing length. Okay. Again I'll write the same formula, drawing length by actual length. So we have the RF, that is 1 by 400. So we have the drawing length of we have to take 50 meter. Drawing length we'll be substituting each one in here. So actual length of 50. We need to find out the drawing length here. Okay. So drawing length is equal to 1 by 400 centimeter into 50 meter. So 50 meter we can again convert to 100 centimeter. So double zeros get cancelled. So here we get drawing length of 12.5 centimeter. Okay, this is what the drawing length. Okay, subscribe to my channel, hit on the bell icon for the latest notifications, and share to maximum students for the maximum. So first I will be drawing one horizontal line for a length of 12.5 centimeter. I will be marking that. Okay, I'll be giving this as AB. Now we have to divide this line into 5 equal parts. Okay, because we have to draw a plane scale of length 50 meters. 50 means 5 parts we have to do. So how to divide this AB line into 5 parts? We have to divide the AB line into 5 equal parts. How to do that? I will be drawing one line from the end corner A, less than 90 degree line. Okay, and by taking compass I will divide this inclined line at an equal parts, equal 5 divisions. Okay, so from the end A, cut the 5 arcs here. The fifth cut arc point we have to join with the B point here. Using the roller scale, I will be connecting it. So we need to draw the parallel lines here. This parallel you can connect so that it will be equally divided into 5 parts. Like this, parallelly you have to draw the line. Now it is equally divided into 5 equal parts. So you can give the namings as 0, 1, 2 and 3 and 4. Okay. Now I'll be drawing the vertical line here at a height of 1 centimeter on the corner end of AB. This is nothing but 50-meter scale it is. Okay, each division it is 10 meters. Okay. So here vertical line again 1 centimeter you have to draw. So here I will be marking this as C and this is D. Okay. So where exactly we have cut it, right? Exactly vertical lines we have to draw to show the total 5 divisions here. Okay. Now here within this you can see each box here it is 10 meters. So within this 10 box meter again we have to divide into 10 equal parts to show each one division by 1 meter. Okay, I'll be drawing another 30-degree angle line above and we need to divide this line into 10 equal parts. Okay, so take the here compass with the length a little smaller. You can count it how many equal divisions you have done. You have done till 9. So this is 10th one. Now join the corner point with that vertical edge of B. Parallelly you have to draw the lines here. Okay, now here I'll be marking at exactly 5 centimeter, marking the midpoints here. In order to show 1 meter, 2, 3 and 4, we can show it here exactly in the 1 divisions. Okay, so we can the equal divisions we have cut it, right? We'll be drawing the vertical lines to show 1 meter, 2 meter, 3 meter, like that. Okay, so this is the plane scale, it is done. So you can see these individual divisions were there. It is 1 meter. Okay, so it is 0 1 2 3 4 5 6 7 8 9 and 10 meter. Okay, total it is 10 meters. We have divided into each one of them by 1 meter. Okay, now we have to show the dimensions of 44 meter on the scale. So showing it is very easy. It is, you can see it is, this is 40 meter. Okay, so all this we have to show in meters here. So draw one vertical line here, and in the smaller lines we have to draw a line for 4 to indicate it is 40 plus 4, so it is 44 meters. So bigger divisions, it is each box of 10 meters. This smaller division, it is of 1 meter. So the total length here, it is 44 meter. Thank you all. Thank you for watching the video. Subscribe to my channel. Hit on the bell icon for the latest notifications. Welcome to Engineering Visualization channel. So today we are going to do a problem on diagonal scale. If 1 centimeter long line on a map represents a real length of 1 meter, calculate the RF representative factor. Draw a diagonal scale long enough to measure up to 50 meters. Show a distance of 44.5 meter on it. So first we have to find out the RF here, representative factor. Drawing length is, it is 1 centimeter and the actual length is 4 meter. 1 centimeter into 1 meter is equal to 100 centimeter. Okay, 1 by 400 is the RF, that is representative factor here. Okay, so using this representative factor, we can able to find out what is the drawing length. So here in the problem, the actual length given, it is 50 meter. So for that, what is the drawing length, we can able to find out from this. So drawing length, the same thing I am going to write here. So actual length given here, it is 50 meter. Okay, so rearranging this, drawing length is equal to 1 by 400 into 50 meter. So it is 1 by 400 into 50 into 100 centimeter. Okay, 100 get cancelled here. So if you do the simplification, it is 12.5 centimeter. That is what the drawing length for the diagonal scale. Okay, first we need to draw an horizontal line for a length of 12.5 centimeter here. Okay, so using the scale, I'll be drawing a length of 12.5 centimeter. I'll be marking 12.5 here, and from the other end, drawing a horizontal line for a length of 12.5 centimeter. I'll be marking this as A and B. So here the vertical length from these corner points, I'll be considering 4 centimeter. Okay. So I'll be marking this as CD. Okay. Now here this AB length we have to divide into 5 equal parts. Okay, in order to make the diagonal scale 50 meter it is. We have to divide this AB line into 5 equal parts. So the corner end of here I'll be drawing one angle line that should be less than 90 degree. Okay. Now using the compass, I'll be cutting the 5 arcs here, so that it will be divided into 5 equal parts. First arc, second, third, fourth and fifth. You can subscribe to my channel, so you can share to maximum students so that they can be benefited. Okay. Now the corner arc point has to be joined to the point B here with the help of the scale. So parallelly we can connect here. We need to draw the parallel lines. Okay, now you see it is divided into 5 equal parts. I'll be drawing the vertical lines. Okay, can mark this as 0, 1, 2, 3 and 4. Okay, so here each of the parts were of length 10 meter. Okay, now we can divide this. You see 10, 20, 30, 40, 50 meter. Total it is 50 meter scale here. So the first one we are going to divide into 10 equal parts. Okay, we'll be drawing another angle line that is of less than 90 degree. So take a compass and cut the smaller arcs here. So total 10 arcs we need to cut here. Can count on it how many arcs you have cutted. So total 10 arcs we need to cut. Then join that last arc with that corner point, and we need to draw the parallel lines here. Okay, so carefully you can draw the parallel lines. Okay, now we will be marking the reference points here below the line so that it will be divided into 10 equal parts. So that is your 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so here we need to connect this. You can mark 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so diagonally we have to connect. Okay, so this 0 point we have to connect with the 1 here. Okay, 1 with the 2, like that we have to draw. Okay, because this is a diagonal scale. Connect 0 point with the 1 here. Okay, and then 1 with the 2, like that we should connect here. Yes, 0 with the 1 we should connect. Same way 1 with the 2. Okay, 2 with the 3. Okay, point number 3 we should connect with the 4. Point number 5 we should connect with 6. point number 7 with 8, like that we should draw the diagonal lines here. Okay, so that's how, so we should connect it. You can see all these were are meters. Okay, the total 50 meters, and this is 10 meter, and 10 meter equally divided as 1 2 3 4, like that. Now the opposite end, that is opposite edge, we have to divide into decimeters. Okay, so to divide into decimeters, I'll be drawing another angle line, so that will be less than 90 degree. Okay, again we have to divide this into 10 equal parts. So take compass and take the smallest length and cut the arcs here. Total 10 arcs we need to cut here. So here I am cutting the total 10 arcs by counting and cutting it. Okay, now join the last cut points with that corner end. Parallelly, we should draw the lines here one by one. Guys, you can subscribe to my channel and hit on the bell icon for the latest notifications, and share to maximum students so that they can be benefited. You can write 0, 1, 2, 3, 4, vertically you can mark 5, 6, 7, 8, 9, 10. So that's what the decimeter here. Okay, you can show this as decimeter. So this one, it is meters, total 50 meter, and this is also meter. Okay, now we have to show the dimension. Okay, dimension of 44.7 mm, 44.5 mm. Okay, so for our easy understanding, we'll divide into smaller parts here, that is 40 mm plus 4.5 mm. So sorry, 40 meter plus 4.5 meter. Again 40 meter plus 4 meter plus 0.5 meter. Okay, so we know that 1 meter is equal to 10 decimeters. So same thing we can continue here. 40 meter plus 4 meter plus 0.5 into 10 decimeter. So totally we have 40 meter plus 4 meter plus it is 5 decimeter. Okay, so now you have to see here, it is 40 meter means here it is already shown, it is 40 means here it is. Okay, so 40 meter means here we have to draw a vertical line for 40 from this end. Okay, now 4 meter, you can see 4 meter, and 4 meter means this line, correct? And 5 decimeter means we have to see in the decimeter scale, we have to see the intersection point. Okay, before that I'll be drawing these horizontal lines. Okay, parallel horizontal lines we have to draw here. Guys, you can subscribe to my channel hit on the like button and share to maximum students so that they can be benefited. Okay, now we can see the 4 meter and 5 decimeter. You can see here 4 meter and 5 decimeter. So 4 here and 5 decimeter we have to see here. So we have to take the intersection point of 4 and 5 decimeter. Okay. So from there we need to draw one vertical line. 4 meter and 5 decimeter. The intersection point we have to take and draw one vertical line. And show the dimension. So dimension here it is 44.5 meter. Thank you all. Thank you for watching the video and share to maximum students so that they can be benefited. Thank you all. Welcome to Engineering Visualization channel. Today we are going to construct a scale of 1:40. So 1:40 means it is nothing but a representative factor RF 1/40 to read meters and decimeters and long enough to measure up to 6 meters. Make a distance of 4.7 meter on it. So first we have calculated here representative factor is equal to 1/40. So we know the formula RF is equal to drawing length by actual length 1/40. So here using this we are going to find out the drawing length here 1/40 into 6 meter, 6 into 100. So by doing the simplification we get the drawing length, and then on the drawing length we have to mark this 4.7 meter. So this is how we have split it, 4 meter plus 0.7 meter into, okay. So using the drawing length, so I am going to draw an horizontal line of distance 15 centimeter. Okay, so we will be drawing one horizontal line for a distance of 15 centimeter. I will be marking this as AB. Okay, this 15 centimeter drawing length we have to show it for 6 meter. That means we have to divide this line AB. So we have to divide this line AB into 6 equal parts. 6 equal parts we have to divide. So for that I will be drawing an angle line from the reference point of A. So less than 90 degree. Draw an angle line for an angle less than 90 degree and then take compass and cut 6 arcs here. You can take any length, okay, approximately can take, and cut the 6 arcs here. Okay, 6 arcs we have cut it. Now we have to join that last cutted arc point, right, with that end line B here. So try to join. So using this scale we have to draw the parallel lines here. So using the roller scale, I am drawing the parallel lines. Okay, now we can mark this as 0, 1, 2, 3, 4, 5. Okay, so totally it is 6 meter. 1, 2, 3, 4, 5. Okay, so now I'll be constructing a vertical height of 1 centimeter. Okay. Okay, subscribe to my channel, hit on the bell icon for the latest notifications, and share to maximum students so that they can be benefited. Now I'll be drawing the vertical lines. Okay, so this, it will be divided into 6 equal parts. Okay, each division it is 1 meter. Six equal parts, with each part here it is 1 meter. Now the 1 meter we have to divide into, so 10 decimeter here. Okay, so we have constructed the scale for 6 meter. So on this AO, I'll be showing the 10 divisions. So I'll be drawing another angle line, so that will be having angle less than 90 degree. Okay, here we have to divide this line into 10 equal parts. I'll be taking compass and measuring the length that will be lesser, and cutting 10 arcs here. You can count the number of arcs. Okay, so that you have to exactly divide that 1 meter line into 10 equal divisions. Okay, now after we have cutted the arcs, right, you have to join with that O end point. Okay, now we'll be drawing the parallel lines here. I will be writing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is divided into 10 equal divisions. I will be drawing the vertical line using this roller scale. Now we have to show the dimensions here. So this is decimeter scale. So I'll be writing the same thing. Decimeter. 1 meter is equal to 10 decimeter. Okay. So since this is meters, I'll be mentioning the same. Okay. So now I'll be writing the representative factor 1 by 40. Okay. So we have to show this 4.7 meter. So first I'll be showing this 4 meter here. So I have divided this 4.7 meter into 4 meter plus 0.7 meter. 0.7 into 10 decimeter is equal to 4 meter per plus 7 decimeter here. Okay. So first I'll be showing the 4 meter here. Exactly at the 4 I'll be drawing one vertical line. And here at this 7, okay, 7 decimeter will be showing here. So I can count the lines, and at exactly at the 7 line I'll be drawing another line, vertical line. So this is nothing but your 4.7 meter. So if you like my video, you can subscribe to my channel, hit on the bell icon for the latest notifications, and share to your friends and to maximum students so that they can be benefited. Thank you. Welcome you all for engineering visualization channel. Today we are going to construct a scale of RF 1:54 to show yards and feet, and it should be long enough to measure 8 yards. Okay. So in this problem we need to construct a scale wherein they have given RF, that is representative factor, that is 1 by 54. So we know the formula, representative factor is equal to 1 by 54 into drawing length by actual length. You can see that 1 yard is equal to 3 feet, 1 feet is equal to 12 inch, and 1 inch is equal to 2.54 centimeter. So you can see here I have done the calculation to find out the actual length. Okay. So here given in the question 8 yards is equal to actual length and 1:54 is the RF. Okay. So using the formula, substituting all the values and doing the calculator, so finally we got the value of 13.54 centimeter is the actual length. Okay, this is the length we need to draw using scale. Okay, in that scale we are going to show both yards and feet, and then we measure one example as a length. Okay, I'll use the scale and I'm going to measure this 13.54. Please follow the video till the end. You can able to understand it. Okay, step by step. Don't miss and don't skip. So mark a point and draw an horizontal line. Okay, you can give this as A and B. And now here you can see this scale we have to divide into 8 equal parts because we need to make this scale as to measure 8 yards. That is dividing this scale line into 8 equal parts. So draw an angle line that should be having angle less than 90 degree, and take compass, take any length and cut total 8 arcs. So can count. Okay. So total 8 arcs you need to cut because we need to divide this line into 8 equal parts. So after cutting it, the final arc point you join with the BV using scale. Now using roller scale, you draw the parallel line, join all the arc points with the horizontal line. You can join using roller scale, draw the parallel lines. Okay, now we will draw width, give the scale for this width. I'll take 1 centimeter as height. Okay, for giving the width for the scale. Join these extreme points. Okay, now you join so that it will become total 8 yards. That is dividing this scale into 8 equal parts. So draw the vertical line here. You can subscribe to my channel and hit on the bell icon for the latest notifications, and share to your friends and classmates so that they can be benefited. Okay, now so we got it, and this is our 8 yard scale. Okay, so exactly at the midpoint I am marking a point exactly at 0.5 centimeter, and then drawing a horizontal line alternatively for these boxes. Okay, I'll leave one box and then mark it. Okay, okay, this is what yards. Now we need to mark the length. 0, 1, 2, 3, 4, 5, 6, 7. So total it is having 8 yards. Okay, now we need to mark the feet here. We know 1 yard is equal to 3 feet. So for that, again we have to divide the first box into 3 equal parts. Again I'm drawing an angle line that should be having angle less than 90 degree. Again, taking compass, I'll cut 3 equal parts using compass to divide that line into 3 equal parts. Okay, so join that extreme cut point with that end, join it. So try to draw the parallel line using this real roller scale. Okay, now vertically downward you draw the vertical line. So this box will be divided into 3 equal parts. Okay, so you can give here 1, 2 and 3. Now this is what the feet here. Okay, 1 yard is equal to 3 feet. Now we can show one example as a length here. I'll mark here. Okay, so here we can write this as yard, and here we can write this as feet. Okay, we can measure any length which we want to measure here. That is, I'm going to measure one mark here length. That will be 6 yard 2 feet. We can take that as an example. Okay, so subscribe to my channel, like my video, and hit on the bell icon for the latest notifications, and share to your friends and classmates so that they can be benefited. So this channel is basically useful for first year engineering students. Okay, this is what 6 feet and 6 yard, and this is 2 feet. So we have marked 6 yard and 2 feet. Thank you guys. Thank you for watching my video. Thank you all. Thank you for the support. Hi guys, welcome to Engineering Visualization channel. So today we are going to learn about Vernier scale. So here in the problem, real length of 10 mm represented by line of 5 centimeter on a drawing. So here 10 meter given, it is nothing but the original length. Okay, and 5 centimeter is nothing but the drawing length. Okay, so this is what we find out. Now find the RF. So representative factor we have to find out, and construct a Vernier scale such that at least count is 2 decimeter and can measure up to 25 meter. That is the maximum length. So this is the maximum length which we can find out. Mark a distance of 19.4 meter on it. So representative factor is equal to drawing length by original length. So here drawing length it is 5 centimeter, original length it is 10 meter. So you can see here in the note we have taken 1 meter is equal to 100 centimeter is equal to 10 decimeter. Okay, so 10 meter into 100 centimeter we have taken. By doing the simplification we got the representative factor, it is 1 by 200. Then after that we are finding out the drawing length. So drawing length is equal to 1 by 200 divided by 25 meter is the maximum length. By doing the simplification, the drawing length what we get, that is 12.5 centimeter. So this is what the drawing length, and this drawing length what we draw. Okay, so 12.5 centimeter from the scale. Using the pencil, I'm drawing an horizontal line. Okay, now here I'll give the width of height 10 centimeter, sorry 1 centimeter. Now we are going to divide this line into 5 equal parts because each part will be 5 meter. Total it is 25 meter. So that's what. So this length we are going to divide into 5 equal parts. We know how to divide this into 5 equal parts. So take one line that should be having an angle less than 90 degree. Okay, and take compass and measure any length and cut 5 arcs from the point of A. Cut 5 arcs. Guys, you can subscribe to my channel and hit on the bell icon for the latest notifications, and share to your classmates and friends so that they can be benefited. So cut the 5 arcs. Now using this roller scale we draw the parallel lines where we have cutted the arcs, right, from those points, and drawing the parallel lines. Okay, now you can see that where exactly we got the lines, right. At that point we draw vertical lines so that it will be divided into 5 equal parts. Okay, now we can give the naming for this. So we can give here the naming, and here the first box you need to divide into again 5 equal parts. Okay, so 5 meter is the one box what we have. So total it is 25 meters. Okay, now each one box first I'll divide into 5 equal parts. For that I'll be drawing one line, angle line, which is having angle less than 90 degree. Again take the compass and cut 5 arcs here. Now join with the extreme point, the last arc point. Okay, now using the roller scale draw the parallel lines. Okay, now you can draw the vertical lines where you have connected. So it will be divided into 5 equal parts. Now measuring one length here, in same way we can divide the remaining boxes into equal parts here. Okay. The same way we did it using compass. So here for decimeter I'll be extending this another length here. Now I'll be measuring one box length using compass. Cut it. Extend the line so that so give a width of 1 centimeter. So you can equally divide. So here guys, you can use the compass, measure any one length of a single boxes and cut it. Okay. Okay. Now take a 6-meter box above of that to show the Vernier. Okay. I'll be measuring 6 boxes here. 6 boxes. So from this top point, I'll be drawing an arc. Measuring 6 boxes and drawing an arc here. And extend this line. Okay. From here, can give a width of again 1 centimeter. So here what we have to do is, after constructing a box of 6, we have to divide it into 5 equal parts. So when we do that, each part will get a length of 1.2 meter. Okay, that's what I have written there. 1.2 meter into 10 power into 10 decimeter is equal to 12 decimeter here, each box. Again, for dividing into 5 equal parts, again I'm drawing an angle line. Again taking compass. Here what the same thing we are doing, dividing this 6-meter box into 5 equal parts. Okay. So guys, subscribe to my channel, hit on the bell icon and share to your friends and classmates so that they can be benefited. Okay, now connect with the extreme point using roller scale and draw the parallel lines here. Now draw the vertical lines so that it will be divided into 5 parts. Okay. Here each part of length, it is 1.2 meter, or you can say it is 12 decimeter. Okay, this is decimeter scale. So we can mark each of the boxes by 12. Each of the boxes is 12, 24, 36, 48, 60 decimeter it is. So we are showing the calculation there above. You can see that. So each box of length, it is 24, 12, 24, 36, 48 and 60. Okay, this is what the decimeter scale. So here we have the meter scale. Okay, now we need to mark one length, that is 19.4 meter. For that you can see here. So 19.4 means it is nothing but where we have the 4 here, we have 4 in the 24. So that is I'm subtracting 2.4 meter with that. So the 17 meter what we get. So I'll be marking one vertical line at 24 decimeter, and the remaining length after subtracting that what we get, that is 17 meter. So on the meter scale I'll be marking this 5, 10, 15, 16, 17 here. So at this point we have to mark vertical line, can show the dimensions. So this is how we construct the Vernier scale. Okay. So thank you guys, thank you for watching my video. So subscribe to my channel and hit on the bell icon for the latest notifications, and share to your friends and classmates so that they can be benefited. Thank you guys. Thank you all. Welcome to Engineering Visualization channel. So today we are going to see a problem on plane scale. Construct a scale of RF 1 by 60 to read meter and decimeter and long enough to measure. Here two scales given, meter and decimeter were to measure. Long enough to measure 6 meter. Mark on it a distance of 5.3 meter. Okay. So RF means representative factor. So it is nothing but drawing scale by actual length. So here RF we have substituted, and drawing length. So drawing length we have to find out. Here the drawing length, here the actual length given, it is 6 meter. So in order to draw it on using a scale, we will be finding out this drawing length. Drawing length is equal to 1 by 60 into 6 meter. So 1 meter is equal to 100 centimeter. So after doing the calculation, the drawing length what we get here, it is 10 centimeter. Okay. So using the scale, I'll be drawing a line for a length of 10 centimeter. Okay. Mark 2 points from 1 to 10 and draw a horizontal line. Okay. Now give a width of 1 centimeter for this plane scale. Give a vertical height of 1 centimeter. Okay, now we need to divide this scale into 6 equal parts, because the total length what we have to measure, it is 6 meter. Okay, so we will be dividing this line. So I'll be drawing one line, angle line, that will be having angle less than 90 degree, and by taking compass I'll be dividing 6 parts, that is I'll be cutting 6 arcs. So from this end, starting from this end, so cut 6 arcs, 3, 4, 5, 6. Okay, now join with the corner point and draw a line. So we use the roller scale to draw the parallel line here. Okay, where it is exactly joined, right? At this point we will be drawing the vertical line so that it will be divided into 6 equal parts. Okay, so totally it is divided into 6 equal parts, that is 6 meter. Okay, each box here, it is 1 meter. Okay, so you can give here from here 0, 1, 2, 3, 4, 5. Okay. Okay, now again that one box we need to divide into 10 equal parts. So it is a decimeter. To show that, we'll be drawing another line that is also having length less than 90 degree angle. Then using compass, again I'm cutting total 10 arcs here. Like this you can cut the arcs. Guys, subscribe to my channel and hit on the bell icon for the latest notifications, and share to your classmates and friends so that they can be benefited. Here totally 10 arcs you need to cut, and then join. Yes, here use the roller scale properly to connect it so that it will be divided into 10 equal parts.
Okay, so we have joined. Now draw vertical lines where exactly we have connected, right? Use the scale properly. So draw vertical lines. Okay, now you can give the namings here. Okay, I'll be writing here 2 4 each with a gap of 1, 2 4 6 8 10. So I can give. Okay, so this is meter. This side we can mention, and this side it is decimeter. So related to the scale also I have done so many videos. You can refer to my playlist. Okay, so you can marking distance of 5.3 meter. So when it is divided, it is 5 meter plus 3 decimeter. Okay, first I'll be marking 5 meter. So 5 meter it is easy. So this is 5. Okay, and 3 decimeter means here 1 2 3. So you can connect the third line and draw vertical line to show the dimension. So this is 5.3 meter. Okay, same way we can mark another length. Say we can mark 4.7 meter. If it is divided into 4 meter plus 7 decimeter. So first I'll be marking the 7 decimeter here in the decimeter scale 7, then 4 we can mark. Okay, this is how we can represent the plane scale with the different length. So on this plane scale we are representing both meter and decimeter. Okay, so thank you guys, thank you for watching my video, thank you all.